Okay, DBA4 review. Let's go through these problems here. So, one expectation on the test is I'm expecting you guys to be able to tell right away whether a function will show growth or decay. So looking at this function right here, the only thing that really does indicate growth or decay is that value right there, the base of the power. So since that value there is 2, that means that what we have on our hands here is exponential growth because that base value, that 2, is greater than 1. Reminder, even though it's not for this problem, if that b value there, if that number is, the base is between 0 and 1, then what we'd have there would be exponential decay, but we didn't really have that one. But be on the lookout for that one because it could be either one, so it just depends on that base value. Okay, so let's graph this thing. Let's go ahead and type that function to our calculator. Once we have the function typed into the calculator, I would recommend just getting a picture of this graph. Remember, exponential growth, that's going to be a curve. It's going to go up as it goes to the right. And then to really make this graph, put all the points in place, let's go ahead and refer to the table. Let's just make the calculator do all that for us. Voila, there we go. Now, just use a little bit of common sense when you're looking at those points. Don't graph any really ridiculous points besides looking at this graph here. We only have a peak value there of 9 on the y-axis, so you don't want to go any higher than that. And a couple things to remember about this graph. Make sure that we place not only the points that are going in the positive direction with x. I mean, obviously we have these ones right here, but I definitely still want you to think about these points that are here that are have x values that are less than 0, and let's go ahead and plot those ones as well. So when you have those plotted and have all those points put in there, the other thing I'm also going to be looking at in the situations where I have having you guys graph this stuff is I am going to be looking at how you handle those decreasing values there of x and or of y, and make sure that those values do not cross over the x-axis right there. So remember what we called those in the biz, and this will have some implications later on. Next couple of units, we called that the asymptote. So respect the asymptote, make sure that you don't cross over that when you're looking at those exponential curves. So moving along here, the next two questions, you guys are doing an awesome job with these ones here, converting exponential equations into their equivalent logarithmic form and going the other way around too. So we just have to have a solid understanding to handle these problems properly, have a solid understanding of the conversion of the three terms there. And so if we use this conversion properly here, if we have 3 to the 4th being 81, then that means that we have the log base 3. Notice the base here and the base there are going to be the same. And then what are we taking the log of? We'll have to take the log of a, which comes from that number right there, which is the 81. And then what this is equal to, following here, boom, 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 it's going to be equal to the exponent. So if the exponent was 4, there we go. Down below, let's go the other way around. Base of log is 7, so the base of our exponential equation is going to be 7. And then the power is going to be 2, and then we have 49. Remember, there's only one way to get that right. We're arranging those three numbers. So make sure once you write it in exponential form, you just double check it to make sure that the base to that power is going to give you that answer.